Hi, my name's James Latimer and I'm a scientist here at the Australian National University. Today we're here in the Fenner School of Environment and Society and we'll be looking at some water quality parameters. So most of the water you find will have dissolved material in it, whether it's seawater that has lots of salt dissolved in it, or maybe it's clay and rocks from a river. When an element dissolves in water, it chemically changes and becomes part of the solution, as distinct from when particulates are floating in the water. So you've sort of got these two different categories of material in the water. We use water for a range of different things. We drink water, we use water for irrigating crops, for watering animals, for cleaning things. And so it's important to know what the water quality parameters are in order to test how safe that water is for different uses. So if the water is too saline, that is, if there's too much salt, then it can make people sick, it can make animals sick. If you use it for irrigation, it can make the ground too salty and plants struggle to grow. So it's important for farmers or consumers to know what the quality of the water is before they use it. Different countries have different water quality guidelines and different regulations for what they consider to be safe water for different uses. In many countries around the world, the tap water is not safe to drink, and so individual users, consumers like you and me, they need to treat the water themselves. Let's run a quick water quality experiment. First, we'll test the levels of conductivity in distilled water, which you can buy from the supermarket. There should be a very low level of conductivity if the water has been distilled correctly. Be sure to record the results. First, we turn on our TDS meter and we put it in the water and read off the reading. Here we're getting a reading of 0, meaning that it has extremely low conductivity, below the detection threshold of the instrument. So that's great, that's what we expect. So it's got a low conductivity because it has a very low concentration of dissolved ions. Next, we'll do the same with measure the conductivity of some tap water. Try testing the water from different taps, such as the kitchen or bathroom, and then from an outside tap, and see if there are some differences. Here, we get a reading of 46. So still very low, but higher than the distilled water. Now, test water from another source, such as seawater from the ocean or river water. If you're unable to access these sources of water, you can try mixing up tap water with some salt, and then try adding soil to the tap water. Here what we've done is we've dissolved some salt in tap water to create a high concentration solution. So it looks clear, but let's see what the reading is. Whoop. The machine is maxed out at 999, so it's a very salty water. What about this soil dissolved in water? We get a lower reading of about 450. So even though this water looks much cloudier than this salt water, it actually has a much lower dissolved concentration. Compare the results of the test and work out what water has higher conductivity and therefore more dissolved material. We are now going to construct a water filter made from a drinking bottle, coffee filter, sand, and a rubber band. So I'm going to attach the filter to the outside, which will stop the sand from escaping when I fill the bottle with sand. And it will also filter some of the finer particulates. There we go. Then I'll fill the bottle with sand, which will be trapped inside by the coffee filter. Now we have a very rudimentary sand filter. Let's try pouring some of this quite dirty soil water through the filter and see if we can filter out some of the material and create a lower conductivity solution. Here we go. It's starting to trickle through. Let's give that some time to filter through our homemade filter. So that's finished filtering now. So what we can do, we can take our TDS meter and measure if there was a difference between the before and after we filtered it. So you can see that they're quite different colours, but let's see what their TDS readings are. So before we filtered, we're getting a reading of about 450 to 500, which is quite saline. Still technically safe for human consumption, but from a salinity point of view, but not very tasty. But let's try this post-filter. This is much better. We're getting down to about 240 parts per million of dissolved solids. So while it might taste a little off, it's definitely safe for drinking in terms of how much salt there is in there. Another important parameter of water is the acidity. So we measure acidity on the pH scale. If water is too acidic, then it can damage the humans drinking it, the ground, or the plants you're applying it to. Similarly, if it's too alkaline, it can be damaging. So what we want the water to sit in a nice little range for different uses. In this experiment, we'll measure the pH of a couple of solutions. Here we'll use universal indicator paper. It's very straightforward. You tear off a piece of the paper and you dip it in the solution, and then you compare the colour to the chart on the packet. So let's start with some tap water. So we dip the paper in, a couple of seconds, bring it out, and then we hold it up to the packet. And so here we see it's turning a slightly greeny shade of yellow, which is somewhere between 7 and 6. Now that's pretty normal for tap water, slightly acidic because the carbon dioxide from the atmosphere dissolves into it and forms a very, very weak acid. So let's try another one. Let's try vinegar. So vinegar is an acidic material, an acidic solution, and so we should get a more acidic colour develop. Oh, here we go. So we're getting a much more reddy orange colour. And so if we compare it to the chart, we're getting a pH of about 3, maybe 2.5. So much more acidic than the tap water. And finally, let's measure the pH of this cola. So Coca-Cola is a very common drinking material, very, very common beverage, but it's also a very acidic beverage. So again, we get quite an acidic colour. When we compare it to our chart, we get about a 3. So the cola here has a very similar pH to the vinegar. Thanks for testing water solutions with us today. You can test all sorts of solutions and determine their total dissolved solids content or their pH. So you can test different solutions at home or around your school.